Hello everyone, welcome to the next session on ANSYS CFD tutorials. In this session, we will analyze the branch pipe which we have created in the previous session. We will start by double-clicking on Fluid Flow Fluent. Since I have already created the geometry, I'll just right-click here, Import Geometry. Now I'll double-click on the geometry because I want to add the fluid here. Now I'll go to Tools and select Fill. I'll fill each of these surfaces by pressing the Control button. I've selected the three faces. Apply, Generate. So you can see here now it is two parts, two bodies. Previously it was just one part, one body. This solid is the outer wall, so I'll rename this as wall. And this solid is a fluid, so I'll rename this as fluid. So this is done. Now I'll close geometry. I'll go to mesh and double click on it. I'll first go to mesh and I'll change the default sizing to 0.01 meter and generate. So now you can see the meshing is done. It's a fine mesh created. Now we'll mark the inlet and the outlet. So this is the inlet that we have. So I'll name this as inlet. And I'll name these as outlets. So I'll call this as outlet 1. This is outlet 2. And this side is the outlet 3. And this surface is the wall. So you can see here inlet, 3 outlets and wall. You'll go to mesh again and update. This message is important. After this, meshing is done, so you can close window. Then we'll go to the main screen and double click on setup. I'll select double precision, start. So once the screen opens, I'll go to gravity in the y direction, give the value as minus 9.81 meter per second square. Then I'll go to materials, fluid. Fluent database. I'll choose water, liquid, copy, close. Then I'll go to solid and also change the solid to steel. So I'll go to Fluent database. I'll have to first change the material type to solid. Then I'll choose steel, copy, close, and this is done. So here you can check the two materials have been added. Then I'll go to cell zone conditions, fluid. I'll double click here. Fluid, I'll change material name to water liquid, apply, close. Then I'll go to solid and double click on the wall. I'll change the material name to steel, apply, close. Then I'll go to boundary conditions. I'll choose the inlet velocity. I'll give the velocity as 3.5 meters per second. Apply. Close this. Then I'll go to reference values. Compute from inlet. Reference zone is the fluid. Then I'll go to initialization. I'll choose standard initialization. Compute from inlet. Initialize. Then I'll go to calculation activities, auto save. Every iteration I'll give this as 50. Okay. Then I'll go to run calculations. I'll give number of iterations as 600. Calculate. So now the calculations are complete. The solution has not converged, as you can see here, even after 600 iterations. So you can give the number of iterations as 1000 and run and see. You can see here, the solution has not converged. It is still going straight. It will take more iterations to converge. So we'll close this window now. We'll go to this screen, then we'll double click on results. So now we'll go to inlet, and for this I'll set the render value to 0.9 of transparency and apply. I'll do the same for all the outlets. The wall and wall 1. So now we'll go and click on streamline. Okay. I'll start from inlet and apply. So here you can see the flow. I'll go to animation. I'll change type to sweep animation. I select the streamline. So you can see the flow of the fluid. Now after streamline, I'll go to contour. I'll create contour 1. I'll select here contact region TRG. Pressure and range is local. So you can see the pressure which is created in the pipe. I'll go to render and remove the show contour lines and apply. So here you can see the pressure at various ends on the pipe. Blue is indicating very less pressure, that is over here in this zone. It is very less, it is going vacuum, and in the other region the pressure is higher. It is 2.5 into 10 raised to 2 Pascal, or it is more. Here in the bend somewhere you can also see it is red in certain zones because the pressure is high over here, and in this lower portion you can see the pressure is lower. Now we'll also create the contour 2 for velocity. Here again I'll select contact region TRG. I'll change pressure to velocity and I'll change global to local. In render I'll remove show contour lines and apply. The velocity is low in these branches. It is 1.12 into 10 raised to minus 2 meters per second. It is highest over here, 3.5 meters per second. And in this zone again it is 2.802 meters per second. At this zone you can see the range, that is minimum and maximum of the velocity. So this happened because we have created 3 separate outlets over here, and the water has taken this outlet as you saw because the flow was the easiest over here. It is because of the bend that you can see very less flow of water in these areas. Hence you are not seeing any streamline flow over there like we created at the start. The streamline flow was not to be seen because of very less velocity. As you can see here, it is growing little blue, so because of which maybe the velocity was not enough to push the water through these zones. So you can animate and check the result all the time. You can see the colors of these balls. So with this, I end the session. I hope you understood this analysis of branch pipe. We are going to have few more analysis on these branch pipes because I have not shown you all the options at once. If you have any doubts, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.